Hi everybody, this is Tor Storley and I am back with another video. If you look at my screen here, it's just a blank screen and I already loaded my database. And in case you wonder still, if you haven't watched my previous videos, you may not know this, but if you have, you should know this by now. You can use this .open and then a path to wherever your DuckDB database sits. And in my case, it's called stocks.db. Now it could be called DuckDB or whatever extension you prefer there. So right now I already loaded this and let me just test it to make sure that it's actually loaded. Take this out and just try a basic statement. Describe stocks, which is a table in my database. Okay, so that works. So I already explained this in a previous video, but in case you need to clear the screen, if you're working in PowerShell like I'm doing here, a command window, you can go to Command Palette, and then you see this Control-Shift-P, and then you can create a hotkey. Like notice here, I created a hotkey called Shift+C for the clear buffer. If you say clear buffer, that is basically your terminal. So when I press Shift+C in my Windows environment, you can see it cleans it out. So that's nice because I struggled for a long time trying to figure out how to clear the screen because it gets really busy after a while. So anyways, I'll get the database open and we got the database loaded. So the first thing I want to do, I just want to show you from my table, which I have discussed in the past videos. In case you wonder how I created all this stuff, go back to previous videos and take a look. And I'm not going to repeat it in every video. So notice I created a stocks table. And from that table, I'm going to just run some basic statistics here. I'm going to get the symbol. You're going to see I have a start date and an end date. And the reason I'm doing this is just to show you for all these stocks that I already loaded in the past, going against the Yahoo Finance using my home built Yahoo Finance API. I'm sorry, the macro that calls the API. I'm able to load data. So you can see my data is from 2021, 1109 through 2024, 1108. So there's 755 records for each one of these. Very good. So what I can do now is, what I want to show you is one thing that is new. I'm sorry, it's not new, but I want to show you anyway. I'll point out when I see a new feature. Basically, you might wonder, whenever you have a query and you want to figure out how is DuckDB actually running that query? Well, there's something called a physical execution plan, and then you have the actual execution plan. Now, what I got here is just a description for you. So if you look here, the top down will basically be when you have a logical kind of flow for the query. And you can actually see what happens to the query when you just follow it through. However, the bottom-up approach is what will actually happen. And that's what DuckDB will execute. So you can see here, it will execute it from the bottom up. So then it applies things like filtering, and it uses its own sequence, built-in indexes behind the scenes. And one thing I wanted to do is just show you very quickly how you can actually run an explain plan. And it's very simple. All you have to do is put the keyword explain above the query. So if you look here, you can see I used the keyword explain, and then I just created a basic query where I do a couple of things just so you can see there's something is happening. For example, I queried 3 columns from the stocks table where the symbol is in, meaning I'm using an in clause. But DuckDB is very clever. It converts the in clause into a slightly different variation. It doesn't just use the in. It rewrites the query somehow. And then it also, I'm querying where the data is less than this date, so I get a very few records back. So it's you applying a filter. So let's see what that explain plan looks like. Notice, here's the physical plan, and it does a sequence scan. Remember, behind the scenes, it will create its own indexes and so forth. And it's going to have, these are the projections it's going to apply, the symbol times the return. And then it applies a filter here, as you can see, which is this filter up here. And it comes back with out of all those rows, it only comes back with 756 rows. Remember, there was quite a bit of rows above. If you look at my query here, you can see for each one of these, there's 755 records. So it filters it down right away, which is always a clever way of doing things in query land. First thing you always do is filter, filter, filter. So in order to get fast executions, you need to reduce the amount of data you have to apply. So notice here, it gets it down to 756 rows, and then it applies the second filter, as you can see here, which is this symbol in here. And notice, it uses the equal there, or. You see that? It doesn't, the in clause, it converts it into an equal and or kind of clause here. So that's how it rewrites it behind the scenes. So as you can see, it's a very simple query, but it serves a purpose of showing how you can actually use the explain plan to see what's happened behind the scene. All right, Shift-C to clear the screen. Let's move on to the next query. And here, what I want to show you is a new feature. And you might have seen this before in my previous videos, but this is actually two new features in this query here, or this query statements here, if you will. Notice I'm setting a variable, and I call it table name, and I'm giving it a descriptor of sp500_stats, which is one of the tables I have in my stocks database. Then what I say is select everything from, and then you have to use this query_table. And you also have to use this get variable with a string name. So this becomes a string. If you don't do this, it won't find it and it won't work. So you have to use this, but you have to put it inside a string. In other words, a quote. And then here I'm just limiting it to 10. So it's going to create this variable, and it's just a literal. I could have just put that in here, but I'm doing this to show you the new features. So this is a very cumbersome way of doing it, obviously. I could have just put it directly in here. But I want to show you this query table. So inside like macros, you can use this and passing in any table based on whatever your variable is. And then it will apply that and therefore becomes much more dynamic. So you can use the macro for many purposes. So when I run this, as you can see, sure enough, it comes back with 10 records from that table called SP500stats, which is basically only 2 columns, year and return, for the S&P 500 index back to the 1926 up through 2024. All right, so that's the variable, and that's the query table, which are new features in 1.1. You can also, and I want to show you a second example of this. It's pretty brief. Notice here I'm creating a variable. The only difference here that I want to point out is that this is actually a sub-select, okay? So I'm creating a select statement inside parentheses. And if you're familiar with other databases, if you ever worked with Oracle, SQL Server, Teradata, whatever you have, you could set subqueries into a variable and use that. So here you can see up here, I used a literal, which is just a one string, one value. Here I'm querying many values and put it into this list of names. Even though it's a list object, you could still run like select star from some other table and stick it into a variable and then maybe join it with that in a second statement. So select on nest because it's a list and we want to get it in table format. Again, I'm using get variable, and you gotta put the variable inside a quoted string name. And I give it a name called names. So when I run that, obviously you're getting, the 3 names coming as a table. Okay, very good. Shift-C to get rid of that. Okay, the next thing I want to show you is nothing new, but it's very clever, I think. So I want to at least show it to you. All right, so I have a table, and I'll get back to this in follow-up videos to this one. It's called managers, and it's really a data set you can find in R in the Performance Analytics package, and I'll get back to that later. So here is what it looks like. You have a timestamp, you have a symbol, in this case some kind of managers like mutual fund or whatever, treasury rates, you have a rate of returns, and so forth. So it's nothing special, it's just a table. But notice, here is the symbol in columns. You see that? There's one, there's another one, and there's a few more. So everything is listed by column and like row based on date. Okay, but I don't want that. I want to use a built-in feature of DuckDB that can greatly enhance this. Notice the clean syntax here. Pivot this table on symbol using some kind of aggregation function for, say, return. You see that? For return. So 3 lines is going to do a pivot table. So let's see what that looks like. And sure enough, notice all of these symbols you saw in that one column has been pivoted, and now they are in columnar format for all those rows that were in there. So it's a very clean, beautiful, elegant way of doing a pivot statement. Now, sometimes you can't really do it that clean because there might be some way you have to do it a little different. So let me show you a variation. Okay. Notice I'm using timestamp here, right? But what if I want to void timestamp? I could use a CTE like this. So let me copy paste that over. Same pivot as we did, but then it says select columns, and this columns is a generic way of referencing any column that you refer to. Basically, it could be multiple columns and it will do one by one type of thing. But what this is saying, take all the columns in the managers table, in that pivoted version of the manager table, which is this, and remove the timestamp. So this is what is called a regular expression. And because you have this bracket and you have the up sign, or I don't know what you call it, pointing like an arrow up type of sign, and you list the field name, that will means that, hey, avoid this column from this query here. So when I run this now, notice it removed the first column called timestamp. And only basically the managers columns with their returns are existing back here. So that's another way you could do it. That might be the best way or might not be the best way. So what I want to do now is I want to continue this column that we just did, because that's it's I don't know if it's new, but it's an improved feature, I guess you can say. So let me show you some other variations of this. So let me clear my screen. And remember, it was my Shift-C that took care of it. Let me paste something in for you. Now, this is just a descriptor. And if you look at this one, the columns, I shouldn't say unnest, but that's a little misleading because you're thinking about lists when you do. But when you use this columns keyword, you can actually refer to any column in your query set and perform some action on it. And you can use like wildcards, or you can use regular expressions on it. So I'm giving you some information here. Let's just create, so keep that in mind when you see what's happening here. So when you see like column star or something else. So to illustrate this, let me just create a temporary table. So here I'm creating a temporary table called employees, as you can see. And I'm simply selecting some values for employee ID. It doesn't really matter what it is. First name, last name, salary, hire date, and sales and department. And then I do a couple of more records. So when you run this, it looks like this. So if you look at it, you just have a few columns, but I'm not telling you how many columns you have. These are the columns you have, and this is the data type you have. And there's 3 records in this table, as you can see. All right, so what does that mean? Well, one thing we can do, we can use this column construct. Let me do this. Let me clear it out first. But if you look at the query, you use any value, okay, and I'll get back to what the meaning of this. You use an alias function. And here is the syntax. Columns star means every column. And then you give it an alias and you name it with a prefix of symbol underscore. And then this is like a replacement or placeholder variable or string or whatever you want to call it. It's a symbol of a placeholder. And you can see it here. So you see you have the min you have the max, and you have the symbol. So when you look down here, you can see you have a symbol, 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 symbol. And then, because you have every column, right, for alias, it replaces this /0 with employee ID, first name, last name, salary, etc. And when you get down here, you do the same thing with min, and you do the same thing with max for each column. And the reason for that, of course, is the same thing. You min, prefix it with min, and suffix it with the actual column name. And you do this because you want to avoid any crash errors for naming two columns the same thing. But this really, column star, picks up every column in your query. So because I'm saying from employees, I'm querying every column in that table. So I'm getting all of these columns back. So that's what that star is doing. So I hope you follow me with this. It's not very clean output, but hopefully you understand the concept of this. So let me just finalize this by showing you a better way of doing the columns if you want to exclude fields. Here I'm calling it CTE managers. I'm doing the same pivot as you've seen before here. Then what I do a select, and I'm using unnest because these are going to be lists. And what I happens to do here is, this is my main query, as you can see. And what I want to pay attention to here is, notice this, columns star. So it's going to pick up every column. But the beauty is, inside the columns itself, when you use the star, you can actually use exclude. And remember, you can take out the timestamp, because remember we removed the timestamp before. And here I'm excluding the timestamp, but I want every other column. So notice the nice syntax. Grab every column star, but exclude the timestamp. And here, as usual, is the prefix and the suffix in whatever you're going to do. Now I just added some more statistics here so you can see it, and I also added some casts. So I want to make sure that my min and max are based on numerics, like with decimals. So I'm casting this. I don't know if you've seen this before. You probably have if you watched my previous videos. But this is what I call a quick cast. It's the same as saying cast whatever column you're in as decimal 10, comma 4. That's basically what you're saying here. By using this C++ type of syntax, you quick cast it right into that. So behind the scenes, DuckDB will write cast whatever column you're on as decimals, blah, blah, blah. But here, it's just a very short notation to make that happen. So that's the beauty of this. So notice I'm doing min, max, I'm doing average, I'm doing a geometric mean. And also notice with geometric mean, you got to add 1 to the percentage, otherwise it's not going to work. And also notice that I'm subtracting 1 from the very end of it here. I'm using the sample variance, I'm using the sample standard deviation, and I'm also using the continuous quantile here. So using the third quantile of 75%. And we'll get back to some of these statistics later in future videos. But notice this is a different take on the same. The beauty of this one is using that exclude keyword instead of using a regular expression. So whatever you prefer, this is a much more neater way of doing it, I think. Again, when you run it, you're going to see you get the same kind of result and everything is good. So that is the video for this particular version of part 3. And I look forward to see you in the next video. If you like this video, please, 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 please like my video, and it will help the algorithm to find my videos so people can actually see what I'm doing. I would really appreciate that. And consider subscribing to my channel. That'd be also fantastic. And I look forward to see you very soon for another video. Thank you so much for attending. Thank you.